Friends, welcome to my channel Lemon Coaching Center. Today I am going to explain you 10th standard chapter 11, the human eye and the colorful world part 2 video. Next topic, refraction of light through a prism. Refraction of light through prism. Light through prism. So last video I have explained about the presbyopia, hypermetropic and myopia. I explained and what is power of accommodation. They may ask this for 1 marks, and about I explained. So next let's come to the next topic, refraction of light through prism. So as per in class, the emerged ray is parallel to incident ray. It is parallel to emerged ray is parallel to incident ray. This here it is a prism, you can see this. So here emerged ray is parallel to incident ray. Wait 1 minute. Angle of emerged E is parallel to incident ray D. See, it is parallel to D. They are saying. See, both are having it is going this side, it is coming like that. So it is both have parallel incidence ray. So consider a triangular prism. Prism. So it has two triangles. We can say triangle and three rectangles in surface. It has, we can say, angle between incident ray and incident ray and the angle between the incident ray and the emerging ray, the angle between them, it is called as triangle of prism, as angle of prism. Here in this photo you can see, here they have given PE, or they have said that they are incident ray, PE or incident ray and EF or refractive ray, they have called it as refractive ray. They said it as refractive ray, and FS or emergent ray. They are emergent ray. FS or emergent ray. The light enters to AB. It enters to AB. AB means here point AB here the left side here AB, it enters first, the light enters there. Because of refraction, it bends the light ray, it bends towards AC, and there it joins to air. So the light from here it joined the AB. There, because of refraction, it bends and it goes to straight, and here again it goes and joins to air back from where it joined to the prism. There it goes back and joins. Peninsular ray of prism makes emerged ray behind at the angle of the direction, and it makes the emerged ray other the angle of the direction of incident ray. In the direction of incident ray, it makes an angle. This is called as angle of angle of deviation. It is called as angle of deviation. See here D, you can see angle of deviation D. It is joining the incident ray, that is incident ray G. Incident ray, it is emerged ray, and it is joining the incident ray. Here E is emerged ray and this is the incident ray. It is joining both of them, so that's why it is called as the angle of deviation. Dispersion of white light by vision. Dispersion of white light by vision. The prism has splitted. The prism has splitted the white light into 7 colors. White light into colors. So see what colors are coming. What colors are coming from that end, from the end. See here, the white light beam is going, no, here the arrow mark is there, no, from there we see light is these colors are coming. Which colors are coming, what colors are coming from that C. So these all components of color, these all vibro kayo Vikayo. So these all colors, the violet, blue, green, yellow, orange, red, these all colors that comes or called as spectrum. They all called as spectrum. These all are called as spectrum. It is called as spectrum. What is spectrum means the seven splitting of colors from the prism is called as the spectrum. Spectrum, this vibro is called spectrum. The dispersion of white light into 7 consequence colors is called dispersion. What is dispersion means the splitting of white light into 7 consequence color is called as dispersion. They mass dispersion for 1 mark. Different colors that pass through prism, the white light that become into different color that comes into the prism, that bends a little bit, as you know, little bit. This is how this I will explain. Wait, first I will say that first is that Isaac Newton was first to tell us about the dispersion, the splitting of 7 colors from the white light. When white light comes out of the prism, we get 7 colors. Isaac Newton first said. So first Isaac Newton tried to send the white light into prism. So he did not get more colors than 7, more than 7 colors. Isaac Newton did not get more colors while Isaac Newton tried to put the white light from into the prism. So this photo, what it says means, when you as you know, you sense the white light into the prism, it becomes into 7 different colors. But if you put in front of that only the prism, another prism, that prism will make you the 7 colors into white light. What means you can do it, you can try it, you can keep the prism and put the white light, and you can see that 7 colors will come. And if you want, you can put the white prism, another one prism in front of it, and in front of that colors. Then you can see in the screen that here you can put the screen. There you can see that white light is only coming, not the other 7 colors. So first Isaac Newton did this experiment. How rainbow comes. So it is a natural spectrum that comes from sky. it happens because of sunlight comes into tiny water droplets. When the rain comes, as you know, the rainbow comes little bit rain, because when the sunlight comes into the water is also like a prism. Tiny water droplets, so it splits into 7 different colors. As it is, water is also like a prism. The water droplets into 7 colors. See this image in your textbook they have given. See here the sunlight comes and it goes into the water droplet, and there it becomes divides into 7 colors like a dispersion of light in prism. So next is atmosphere refraction. So you may have seen that the air. So when you burn something, the air, you may see that when you burn something, the air that is that comes up is little hot. It is little bit hot. It is 1 minute. It is little bit hot, but the air that is more up, the air that is more up, it is cold only. It is not hot. Why means? It is because of the hotter air. The air that is hot, the hotter air, it has less density. It has less density dense than cooler air. The air that is cool, from that the hotter air has less density, less dense, so it will become hot. Next, let's know about twinkling of stars. How you'll think that the stars are twinkling. See here, you can see in this image the stars are twinkling. So it is because of atmospheric refraction in starlight. In that light of star, it is because by the light of star, it is because of that refraction you feel that twinkling of star. Light of star enters the atmosphere of earth by refraction. It enters and the light is bended. So it is bended. Star is bended towards the normal. The star is bended. As you know, in your prism you learnt earth is ozone layer is also like a prism. So when it comes to the surface, it took little bit bent. The star is in little different star is in little different position. Little is in a little different position. It is. So in here image you can see the star ray is coming from here, but for us it appears that star position is here. So by that refraction we get refractive index increasing because it is coming towards the earth, so it is increasing. So the ray that comes here, from here it comes, and we feel when we see the star, you feel that the star is shining from there, but the star is little bit far from there. So the apparent star position is here, but we feel but the ray is coming from here, and we find that the star is twinkling when we see it. So this is how it happens, because it is little bit far from the ray that comes to the eye, atmospheric refraction ray. it is little bit far from the star, but we feel that it is near of the star. After that, the light ray or refractive ray comes to our eye, and we see the star twinkling twinkling. So we learned that in the twinkling of star there is a hidden sense. The refractive atmospheric refractive may shows us the twinkling of that star. What is, let's know about next is advanced sunrise and delayed sunset. Why is this? Let's know about that. So the sunrise happens 2 minutes early. 2 minute sunrise happens 2 minute early. 2 minute early it happens. And sunset happens. 2 minute late. Happens 2 minute late. So your question may be why it happens 2 minutes early and 2 minutes late. So 1 minute I will say you why. It is also because of atmospheric refraction. So it is also because of atmospheric refraction. So here you can see at the morning you can see that the sun is 2 minutes early because the sunray comes directly to your eyes. So it comes but here it is horizontal. And here it becomes straight. But the opposite happens where at the sunset. What happens means the sunray comes straightly, but here when you saw, the sunray will become horizontal. It will become a little bit horizontal bent. It will become like prism. So when this happens, so you feel that it is 2 minutes late because it is little bit horizontal, means you will feel that so if the sun must be here straight, so if it is little bit down, then you will feel that it's 5 or 10 minutes late, like that if you feel. So like that only, if it was here in horizontal where the horizontal is written, but if it is here where now the sun is, then you will say it is 2 or 3 minutes late. So this is why it happens. So next topic is scattering of light. The blue color of water, sky, sun, the sunset, etc. Example for this, you can say it as examples for scattering of light. For this Tyndall effect. Next is Tyndall effect. What is Tyndall effect? Let's know about that also. Earth atmosphere has heterogeneous mixture particles. As you may be knowing, you have learnt in your classes, it has heterogeneous mixture particles. It has made of particles are made up of heterogeneous. So the smoke, etc., anything on earth or the same it is made. So the light that comes towards us should deflect it. So it is deflected, means it is little bit deflected, bended. So the phenomenon of scattering of light by colloidal particle is called as Tyndall effect. So if a light comes, or because of smoke or anything, tiny water droplets, water droplets Because of that, smoke or tiny water droplets, if it is deflected, if the object is little bit deflected to us, then we can say it as the Tyndall effect, because it is little bit scattering of light. We can say the phenomena of scattering of light by a colonial object, or by a colonial object means the smoke, tiny water droplets, or anything it may be. By that, then we call it as Tyndall effect. So the math is to explain what is Tyndall effect for 1 marks. Scattering of light. The scattering of light depends. It depends on size of object. See how is the size of objects here. They have said that tiny water droplet. It may be huge water droplet, or the length of the object. How much length of the object it has. On that we can say that whether it is how much the scattering of light we can see. So why we can see the blue sky? We can see the blue sky. You may ask, blue sky. So it is because of air molecules that are the air molecules that are small than the visual lights, then the light that visual light in the sky, then that the air is very much small. The blue color has shorter wavelength. Blue color has shorter wavelength, wavelength, and the red color has high wavelength. So why means, see, if shorter wavelength means it can pass through the air molecules easily, but if it is high wavelength, it may take or it may not reflect more colorfully. So in sky, if you may see sometimes the red sky, sometimes that is because of the some small particles. In sometimes it will be becoming red. Because of the more wavelength, it will becoming red. So that's why you see it. So when sunlight enters the atmosphere, it helps the blue wavelight. It helps blue wavelight to come. Blue wavelight, it will come. The air molecules that I said, air molecules makes the blue wavelength to enter our eye. It makes, sorry, here wavelength, it is blue wavelength. It makes a blue wavelength to enter our eye. So the blue wavelength will be more in sky. As you go in aeroplane, this is because you may have saw the red wavelength became less in fog and smoke. Like that only, the blue wavelength become more powerful. Like that only, blue wavelength become more color in that sky. So next is arrangement of colloidal particles in. So observe arrangement of scattering of light in colloidal solution. So how it's arranged, let's know. So first I will show you image, then you think what you will see in that image, what in your mind comes when you see that image. So see this image, the light is coming. So by seeing this image, what in your mind is coming? So you may thinking that the light is coming and it is bending because of incident ray here. Because of incident ray it is bending, colloidal solution is bending, you may think that. So what happens means the light comes and it hits to sulfur plate and it bends as you learnt when the when a in that prism, when the light ray comes, it goes and it hits and it bends. Why that is that? You may think it is because of this colonial, it is because of the normal ray is entering, and because of refractive ray, because it is refracting, and incident ray that are making it to bend, passes through the water and it hits the wood and the ray that hit the wood stop there only, and other rays goes in that gap. So here another small plate is kept, that makes it to become the light, that makes it to become light as one ray, that makes the different rays to become a one ray. It makes, as you see here, one ray was coming, when it becomes like this and it makes it as one ray. Color of light says us about the bluish color of sky, bluish color of sky. So you learnt why, because of it is high wavelength, blue color is high wavelength, so it is bluish color because of scattering of light, you learnt. And it also says us about reddish color of sun, color of sun. Why the sun is red? Reddish color of sun during sunrise and sunset. In sunrise and sunset, why it is reddish, it will say as. So the reddish layer of sun, sun it passes through horizontal. See here, you can see that sun near horizontal, passing through horizontal, and it pass through a layer of air, and the layer of it pass through a layer of air and the high layer of atmosphere. In more high atmosphere it passes through, then it reaches to our eye, eyes after passing through the atmosphere and horizontal, sun near horizontal. When it comes through layer of air and then through layer of atmosphere, then it comes to our eyes. So it will be light color during noon, as you all know. As it becomes evening, the wavelength of the blue is less, so the sun gives high wavelength for sun. I said why the blue sky is blue, because of less wavelength the sky is blue, and because of high wavelength the sky, because reddish color has high wavelength, so the sky will not be red. But the sun gives high wavelength, the reddish color appears. Thus the reddish color appears. So this was your chapter, the human eye and the colorful world. So I think you understand this chapter. So okay friends, like the video, comment on my video and subscribe my channel and my coaching center for more video. I will see you in my next channel. Till then, take care and have a nice day friends. Bye friends. And tomorrow I will explain another one chapter. Till then, take care and have a nice day friends. Bye.